let's get started. We are going to do lecture 9 and 10 today, and it's going to cover the second part of object orientation. Really, we've seen it all already because I talked ahead on the last video, or the last lecture I did. But now we'll see an example, kind of refresh your memory, put all the pieces together, and then lecture 10 is all about comparing object oriented design with structured analysis. And that'll kind of put the pieces together in terms of why we do both. And then that'll be enough for one day. That'll be enough for today. So let's see what we got going on here. Let's see. So the requirements. In terms of the long term, what are we looking at? In terms of your projects for this course, we know what happens at the end of the semester. Well, probably not going to. Well, actually, I've had some people implement projects that they've created or ideas that actually ended up getting implemented, because usually they borrowed something from the company they were working at or something of that nature. But it is actually kind of nice to see all this work happen and everything that you're doing actually turn into a project. But for you, for the purposes of this course, you're not necessarily going to have anything that you're going to do anything with at the end of the course. Instead, you're probably going to just chalk it up as a learning experience and never visit that topic again until you have to do another term project and then use the same topic over again because you're familiar with it already. But in the real world, what we're looking at is preserving the work that we've done, being able to utilize that in the implementation and in the development, and be able to take that and actually make a marketable product out of that. And so requirements, design, and implementation are all supposed to work together, which is why you spend a year and a half or a year putting together a requirements doc, a design document, and all of the architectural diagrams and things that we're putting together. And looking in terms of reusability from future projects. If you're a software engineering firm and you've done all this for one project, you're gonna hopefully the next time around it's not going to take you as long, and hopefully you'll be able to do a better job, and maybe you'll be able to reuse some components or reuse some thinking that you've done. In terms of remembering the definitions, and what the slide is showing you, what the requirements is supposed to be giving you is the what, the design is supposed to be giving you the how. And keeping that in focus, we could come back and look at the hows from the whats and compare how some implementations may have been better than others, etc. In terms of what the requirements specification actually is, it's a specification in terms of the nothing outside of the what. So our analysis that leads into our design is supposed to be teaching us the how. And we're not supposed to think about it ahead of time until we've done the analysis, and then we come up with the how in terms of what we're implementing. If we take the what and we apply it to an object-oriented methodology, what we end up having is kind of a structured way of going about developing the how in terms of the solution to the problem. And object orientations we've seen so far, we're modeling objects from the basis of what the methodology entails, and then we take those objects and we show different characteristics about the objects. The object is the class. So from the object diagram, we created a class diagram from that. Where this part 2 of object orientation, this particular lecture, kind of gets into the concept of taking and actually looking at the implementation details from a design perspective. So we're taking our analysis and we're actually implementing the design right now in terms of the class diagram, in terms of the sequence, the hierarchical, all these other specialized diagrams that we're making from the object. And as I mentioned previously in a couple weeks back, hopefully I mentioned it, just because we're doing an object-oriented analysis approach, we don't necessarily have to skip systems analysis and design or structured analysis. We can still do that. So it's really common to do a entity relationship, a data flow, and then start doing your object-oriented diagrams, only because it gives you a more complete picture. One methodology doesn't solve all. So given a real-world scenario, you pretty much have to decide on classes that you're going to use for the system, and this lecture takes it from the object approach and creates a class diagram in a very similar manner. So what you're going to look at is a noun extraction approach, which we've already seen, but that was in relationship to objects. Now we're kind of focused on the classes to extend the concept a bit further. What terms do the users and the implementers use to describe the system? Those end up turning into candidate classes. If you say, I have an accounting system, and my accounting system has a reporting module. So it's very common to call the system an accounting system, and then we have a reporting module, receivable modules, payroll modules, all these different modules. Could be classes, could be abstractions of classes. So a lot of developers actually take that approach, because then the end user can actually say, look, we've implemented the reporting module. Here it is. It's the reporting module you asked for. And then each candidate class can be specifically defined now if we take it a bit deeper. So before we were looking at object diagrams, now we're looking at taking and defining each one of the classes and looking at the identity states and the behaviors that are associated with it, and actually developing the interaction that these classes are going to perform. Each class may also have a set of responsibilities, as we saw before. And this kind of goes back to that CRC concept, the class responsibilities and the collaborations, which is the identity state and the behaviors, apparently, if you translate it into different terminology. But the responsibility would definitely be something that the class is supposed to be doing, and otherwise it doesn't really have an existence. We shouldn't have classes in the system that don't really do anything. We should X those out, get rid of them. Otherwise we have wasteful, inefficient code. The responsibilities, another thing that we have to look at is, are they evenly balanced among the classes? Or do we have one class that's doing all of the work and none of the other classes are doing anything? So we can load balance our responsibilities among all of the different available classes, which is not a bad idea either. And then also considering what attributes and operations does each class carry out in terms of what it's accomplishing as well. So here's that noun identification example again. So humor me for a few minutes as we go through this. I don't like this approach actually, because it doesn't, it's like here's our identified nouns. I think it just creates too many classes to start out with. But some people need some sort of a methodology. Math people, they need a structure to what they're doing. You can't just guess at it. There has to be like a pattern or a method to follow. So this is the one that's actually the most commonly practiced method for the most part. So library in red here. Oh yeah, it does show up in red. That's good. Contains books and journals. So we have library, books, and journals, and we have candidate classes that come out of this. We saw this. This is the same approach that we're using to create an object. Object diagram. We use the same approach to establish or to create a starting point for the class diagram as well. So we have library, book, journal, copy, and all these little things here. Then this should be over here. There's an extra space here for some reason. And the name of the system, the event. These are just some descriptions that may end up being properties in the long run. And then we look at the relationships between the classes. We say a book is an item, a journal is an item. Well, we have items. We have a lot of items. An item is an item. Here we have item. Well, library owner. So, is item really needed? Not really, actually. An item is an item. Well, a book is an item and a journal is an item. So we start looking at the logic of the candidate list that we've created. And then we can start scratching items off the list to figure out which ones may or may not necessarily be duplicates. And then we take a look at the operations, going back to the class responsibilities, the operations, the data that's going to be holding. And then we look at this and we say, well, a library member borrows a copy, returns a copy, member of staff can borrow, return. Items not really needed then in terms of the concept. So we can decide to scratch item off of the list. And what we'd end up doing is taking this big list and we shorten it down after looking at, all of these different nouns, because, the description could be repeating itself, could be talking about different things that are all the same item, So in this particular example, item was really the only thing that we could possibly scratch out. But we start with a big list and we narrow it down to smaller. And then we build the first iteration of the class diagram. In this particular example, we have a member of the staff that is, that works with the library member, is a member of the staff. And we have a journal, a copy, a book. A copy is a copy of a book. And it looks like an entity relationship diagram. It looks like an object diagram. Looks like a class diagram. It's actually all three. But there's different levels of detail. In the class diagram, as you notice, now we start breaking the boxes out. And if we were to take away these lines right here, and we had open boxes and we just put the word library member in there, we would have both, actually with cardinality and everything here, we would have both an entity relationship and an object diagram. Because we've put the lines in here, we're calling this a class diagram. Because we could put in the other two components, and then what we have is there the identity, the states, and the behaviors that belong in these three different boxes. So we have the identity as far as we've gotten. So it's very common to see it written out like this, because then what you can do is use that as a starting point and say these are the classes that I'm intending to put in here. Because what we could do is add classes like controller classes and stuff, and I think we covered that in the last lecture. And after we've looked at this and said, well, what's missing in terms of the functionality? And then in some of them, we might actually put in some states and some behaviors, given what we're looking at. So let's take a look at the rough sketch of a wholesale system. So wholesale merchant supplies retail stores from stocks of goods in a warehouse. What classes would you use to model this business? And this is kind of the type of questioning that you'll end up getting in terms of like maybe the final exam or something. And it's kind of a common question. What? It's a wholesale merchant, and he supplies retail stores from stocks of goods in a warehouse. Well, we got a retail store, merchant, order, product, shipment, invoice. These are kind of items. You can take and pull the nouns out of there if you want. Wholesale, merchant, supplies. We end up with a bunch of retail store, merchant, order, a bunch of odd nouns that we pulled out of there. And then we can kind of like look at it and say, well, retail store, what information, what states would we have for the retail store? And we could start filling in the boxes essentially. How we're going to locate them on the screen. This kind of changed in terms of the order a little bit. We can reorganize a little bit and say, well, retail store, we only know there's going to be a name, an address, contact, financial information. And reversals, those would be returns. Well, we're going to have damaged goods, return, wrong item. Shipment's going to have this stuff. And the responsibilities could be, tracking status of shipment. So we could put responsibilities in here. We could put method calls in here. It doesn't necessarily have to show up in this particular form, which is what this slide is pretty much showing us. But it's interesting that they've added another box to here. You can put any information you want inside this box. It's not like a set in stone. It has to have those three components. So in this particular box here, we have methods, we have states, and here we have responsibilities. And we have 1, 2, 3, 4 sections instead of 3. Optional, I should say. Which tells you there's no standard and object-oriented design either. People just do what they want. So we can expand the class by modeling, let's say, modeling the financial information. Up here we had some financial information over here. So we could say, well, the retail store has an association with a transaction. Well, the transaction usually occurs at the retail store, and it involves a payment and an invoice, perhaps. So which class is responsible for the financial records for the store? Well, the diagram doesn't actually show you. So you could put something in there, add something in there, or specifically specify. So the point I'm trying to illustrate is that it depends on what you're trying to show in the diagram as to what level of detail you're going to put in the diagram. And you would probably put a caption above or below the diagram saying, this is going to show the financial. This is going to show like the financial records or something. And here's modeling the invoice. We have this kind of a question mark going on here because we have the retail store that has an invoice, and the invoice has got items from a parts list. So if it's this manufacturing of this auto retail manufacturing company, and we have a shipment that's associated with the invoice. But how do we know what shipment is from what store, or do we care? So we have this big question mark going on here between. And this is something we might put in the diagram to take back and show the user and say, well, we have a retail store and we have invoices because we have purchases. Let's say, and actually as a classic example, you ordered it online and it's a chain and there's stores throughout the entire United States. You're in California. So what store are they going to ship it out? Hopefully they ship it out of the California store, but it might not. The shipment might not come out of a California store if the item's not in stock there. And what do you care? It's being shipped to you. So it could go out of Colorado or something, or Arizona, or another local neighborhood state or something. And here we have the plus and the minus in terms of the private and the public. If we wanted to take it a step further, we could indicate with our methods down here whether or not we're going to make them part of the public or part of the private interface. And again, this kind of goes back to, well, if you've got some object-oriented programming experience, you know about public, private, and protected. And if you're the one drawing the diagram and the audience for this diagram is somebody who is going to be implementing this and not, like, let's say, the customer, then we can say, you know, good shipped is going to be a public thing method, and then send an invoice is going to be a private method that's being run within this class, this invoice class, and we're not going to have exposure to it outside of this class. And we can kind of indicate in the diagram, depending upon the need, what it is we're trying to show. Those different types of scenarios as well. So lessons learned, there's no single correct design. And then we should probably highlight that, put it in bold, underline it. During the design process, elements are going to be hidden. Even if you take an object-oriented design approach, as we've seen here, there's no standard. You know, we're going to put the public and private in here. We're going to actually show this correlation. And the downfall to this entire methodology is that we're only showing what it is we're intending to show. We're leaving out a lot of information. And this is where we go back to and we say, well, the entity relationship diagram is going to show everything. It'll show more, but it doesn't show the same level of detail. So here we have, you know, the ability to add stuff to the entities or to the objects and actually show associations instead of relationships. And we're able to show them in a lot more detail, in a lower level of abstraction, what's going on. And it adds to the complexity, but it also takes away from the big picture as well sometimes, depending upon what we're showing. So elements might be missing, they might be hidden, and the model may not be consistent. So the diagram is not the whole design. Diagrams must be backed up with specifications. So we take, normally with an object-oriented approach, we rely more on the requirement specification than we would in a structured analysis approach, because in a structured analysis approach, the diagramming that we're doing is mimicking, or it's strongly built on those requirement specifications and those specs. And so we don't necessarily have to keep flipping back and forth. We can actually take a look at that entity relationship diagram and kind of, you know, kind of see a big picture of the entire system. So in object orientation, you do that entity relationship, you do that data flow for the same kind of similar purpose. So you don't have to go back to thousands of pages of requirement specs. You can see it. You can see those thousands of pages of specifications right there in the diagram. And then you have your supplemental object-oriented ones. So that's why I'm, you know, kind of reiterating the point that it takes a lot of different levels of abstraction, and it takes you know, combination of a lot of different types of approaches to actually get a complete design from it. So levels of abstraction. So the complexity obviously depends on the level of abstraction that we're looking at. The more detail, the lower level of abstraction. The fewer details, the bigger the picture, the higher level. So imagine yourself on a helicopter coming down and up. You can't see the ground as clear as you can when you're sitting on top of it, and you're inside of it, or you're on top of it. And that would be a very low level of detail. So low levels of abstraction are needed for implementation. Higher levels are needed to show the overall system. So you would show the higher level diagrams and abstractions to the users, to the stakeholders. The lower level ones to the implementers, to the outsourced people that you've hired to build this particular project. Two approaches might exist: the model and the entire system at the same level of abstraction, but present diagrams with different levels of detail. That's what you're doing for your projects. You're doing the first approach. And the second approach might be model parts of the system at different levels of abstraction. That's what object orientation aims to achieve. It takes different levels. For example, the sequence diagram or the activity diagram, only showing you activities or sequences or states or something. not showing you classes or objects or anything. But those classes or objects are in there. So object orientation is kind of, a step beyond looking at the big picture and then dissecting different levels of it. Instead, it just takes and separates out the big system into different levels, and you look at each one of the different levels to get an understanding. Which is why you can kind of put them both together and get the best of both worlds, essentially. So, and here's an example of a component diagram. This is a high-level diagram. This is Hello World. So we have the Hello World HTML page. It's an applet for Hello World HTML page, and we've got the class that was written from the source code, and we've got a picture that shows up. This is Hello World with a graphic picture on it. So, and this is, believe it or not, you'd think, well, it's Hello World. But if it were a huge system, you might not know which component works with which other components. You might not know that this HTML document has this graphic and it also has this class on it. So, obviously in a more complex system, it would make better use. And we have the actors and the use case diagrams that we've seen before. This is kind of a summary of the techniques that we've seen so far. The actor here is the user of the system playing a particular role. And the use case is the task that the actor is actually performing. So we have a borrow a book task. We have a book borrower in terms of the actor. And we put those pieces together and we create scenarios out of it. It gives us yet another lower level of detail on the component. And it's going to show us something completely different than a component level. So the scenario is an instance of the use case. And the actor is the role, not an individual. So it's kind of like entities. It's kind of like going back to the entity concept. The object concept. Librarian can have many different roles, can do many different things. And the actor must be a beneficiary of the use case, hopefully. Must be part of the, receive something or give something. And in UML, the system boundaries is the set of use cases. So if the use case crosses over into another system, then we have an integration diagram that we look at. And we say, well, how does this system integrate with that system? And then because we have to look at interfaces. We have interface diagrams as well, which makes UML more complicated than you could possibly imagine if you think about it. And I'm standing here saying it's complicated. It really isn't. What's complicating is that there's so many different types of diagrams. It's finding the right diagram to suit the needs and making the diagram look like it's supposed to look in terms of the type of diagram that you're using. I see a lot of component diagrams that look like object diagrams, that look like use case scenarios, that look like, a bunch of other things, and I look at the diagram going, what is that supposed to be? That's the confusing part. There's too many choices. It's kind of like learning how to program in a language that gives you multiple different ways of doing something. Which way are you going to do it? So too many choices gives you too much, adds confusion to it. So here's the use case of the borrowing of a book, where we have a book borrower who's going to extend a loan and borrow copies of books, essentially. Relationship between use cases here with the uses relationship. The book borrower extends a loan and uses a check for reservation. Uses this, so we can put uses in there. And we're basically looking at kind of a hybrid use case scenario and entity relationship diagram. Think about it. But we're not showing relationships, we're showing associations. So. And then we have the extends, where we have the book, the activity of the borrow copy of book that is extended by a refused loan. So in terms of the development cycle, the use cases are actually kind of important because they're used in a lot of different areas. They can be used right from the beginning to solicit a requirement to figure out what it is we want to do with the system, and then also communicate the requirements back to the user. It can be used in the analysis and in the design to figure out the scenarios, so we can map that out, make sure we're implementing the correct behavior in the system. It could be used in testing to figure out, well, why are we testing? What are we testing? And then how many, basically how do we create the test cases? Well, we can take the use case scenarios and turn them into test cases, so we have at least hit the major functionality of the system. So we have a tool and requirements analysis, easy to discuss to clients, often hard to translate into class models. So we don't have diagrams that can actually easily translate from one to another, which is the other interesting part about UML as a side point as well. Not only do we have a huge variety, they don't translate very well. It's hard to take a use case scenario and turn it into an object diagram or a class diagram or vice versa. So, but you get that in a lot of different languages as well, or different methodologies, I should say. Scenarios are also useful for validating designs and for validation testing. So, who's this in the background? I don't want to do updates right now. Let's make sure I'm still recording. Good. All right, so that was kind of the conclusion of the object-oriented design stuff that I was going to give you. It did give you. If you really want to learn about object-oriented analysis, take an object-oriented analysis course that just focuses on that. That's not very popular of a course these days. It's usually combined with a programming language, and it's usually turned into object-oriented design instead of analysis, because nobody wants to sit around and analyze stuff. They would rather implement it. They would rather design it. So, you know, object-oriented design would be your next course, I guess, if you were really interested in that. So let's take a look at UML versus entity relationship diagramming and kind of conclude with the big picture in terms of what we're doing in terms of our analysis and our design, because this applies to both concepts. So UML is not and can never be a replacement for entity relationship diagramming. It doesn't replace it, which is the common mistake a lot of people do, especially when they assume that they're going to implement their project in an object-oriented methodology. Or, you know, it's going to be a Java platform item. So you can't skip the whole structured analysis and design and just go directly to object orientation. And theoretically, a lot of people are under the misperception that they can, and that causes faults in the design process and makes the design analysis and design take twice as long or so, because eventually they have to go back and start from the beginning. So, not a replacement. And despite the advantages, it's not without its own weaknesses. It doesn't show a lot of stuff that the structured analysis shows, which is why we use them both in combination. And in some ways, UML diagrams are more symbols, making them more cluttered, therefore less easily understood by users. Believe it or not, even those use case scenarios with the actors and the actions can be cluttered to the point where they don't make any sense either, even though they have these nice, cute little, stick figures on them. They still can be very confusing. The class diagrams in UML are a superset of the entity relationship modeling. In fact, we've seen the object and the class diagrams are a superset. And there's nothing that can be expressed in entity relationship diagrams that cannot be expressed in UML notation. But there are many more structures and relationships possible in UML that cannot be expressed in entity relationship diagramming. So start out with ERDs and move to object-oriented design, and then you're working in a good order. You can't work backwards. So let's take a look at see the shift and how the terms kind of correlate. We have an entity, which is actually the class. The instance of an object, instance of an entity is the object. So, in fact, this is the same terminology they teach you in the object-oriented design courses. They say, we implement an object by a class. So an instance of an object, when an instance of the object creates, we actually create the object. The object doesn't really exist until an instance is created, which is how an instance, and we do have instances, we have entity instances, because that gives us our cardinality in the entity relationship diagram world. So we have entities and we have instances of entities, which roughly translate to an equal kind of comparison. We don't have relationships in UML, but we have associations, and we don't have associations. And people, often kind of are sometimes confused about the differences between a relationship and an association. It's like, I always think of it as like, are you friends or acquaintances? So, if you're an acquaintance, you're an association. If you're a friend, you have a relationship with that person. So, we can kind of think about associations for a second and say, yeah, I know all of you guys. I'm associated with you. You're all taking my class. Do I know any of you personally? Some of you maybe, some of you no. So, but we have a connection because you're taking my class. So I have an association, but it's kind of a weak relationship. It's not a full, like I know where you live, I know your contact information. Better yet, I know your names. That might be stretching it for everybody. So I know some, but I can't remember everybody's name. So in terms of the relationship, that's what we're showing. Entity relationship diagrams are showing those strong relationships. So this student takes a class. We're assuming that there's a relationship. There's a lot of assumption that goes on in an entity relationship diagram because we're translating those associations into full relationships. In a UML term, we can take and we can show the role of the association, which we don't have any roles in entity relationship diagram. The concept doesn't exist. Because in terms of an association, we can say a student enrolls in classes, or a student audits a class, or a student dropped a class, or a student added a class. We're showing so many different types of roles in terms of the association between the student and the class. We would have to show all of those as separate relationships, which takes up a lot of room in the diagram and makes it complicated. Because we're not really, and are they really relationships? Does the student have a relationship with a class if they dropped it? So this is a lot more expressive and a lot more flexible and a lot more confusing in the long run. So attributes are attributes. That's the same thing. So classes have attributes, so do entities. They both have attributes. So in terms of mapping it, any entity relationship diagram can easily be mapped into a UML diagram. Well, two classifications. It can be an object or it can be a class quite easily. It also actually does translate into other ones like activity diagrams, depending upon the nature of the ERD. Many structures that cannot be represented on an entity relationship diagram can be represented in UML. UML does states, it does sequences, it does behaviors that entity relationship diagram doesn't do. And in entity relationship diagrams, there are two sides of the relationships to name. And in UML, you also have the option of naming the two sides, but you also have the option of placing a name and a direction on the relationship itself, meaning that, the student drops the class, and the class doesn't have anything association with the student outside of that, and that the student is the one who's dropping the class in terms of the action and the association. So in the UML, ends of the relationship are called the association roles, as I mentioned before. So here's the roles in UML, and here's another example of a person who works for a department. And we have an employee and employer. So between the department and the person for the employment relationship between the two, the full UML notation would look like this. And it's really showing an association. Because do you really have a relationship? If you're an employee, do you really have a relationship with the department, or do you just work for the department? The department is a concept. It's a group. It's a gang. No, it's not really a gang. Actually, some companies it might be, but it's a grouping. And so the person, many employees, works for, and then we're showing the department in terms of the works for relationship as the association, and then we have employer. So it's very common to see in a UML diagram, although this looks like an entity relationship diagram, and it's a UML diagram because it's showing the employee and the employer. The classic way of getting around this problem, and you say, well, I want this to look like an entity relationship diagram, is to put that diamond symbol in here, take away the arrow. And then you wouldn't normally put the role names on here either. So the department acting as the employer may employ a many number of persons as employees. And you might be thinking, well, in this particular case, it is just a notation. The syntax is the same. So the notation includes the role, and each one of the objects in the class is assuming the relationship that's expressed. And entity relationship diagrams do not show or do not include the role information. So that would actually be improper to put the two roles on here. And the relationship itself is expressed by a verb. Well, it's the same thing. The relationship is a verb. Students take classes in an entity relationship world. So it holds up fairly well, and sometimes it's difficult to determine the appropriate word, obviously, especially when you have multiple roles that are going on. Do classes take students, or do students take classes? So takes, is probably not a good word to use, but enrolls in. Has, maybe student has classes, classes has students. So it's kind of tricky. Same problem you have in UML. So if you're creating abstract models with the same relationships, might represent more than one type of an association, the naming becomes somewhat more complex, as we've seen in that kind of similar example. And here are two diagrams that are compared, which are kind of interesting. And we have entity relationship style representing a many-to-many relationship, where we have a student and there's an enrollment, maybe an academic transcript or something. And on the academic transcript or the enrollment, we have course offerings that are on that. So one course offering might be on many different enrollments. Many different students might have many different enrollments as a concept. This could be like, I don't know, enrollment documentation of some sort. And in the UML diagram here showing the same thing, where we have enrollment history, duplicates allowed, in terms of the association, and then we have employee and department as an example that might have employment. I said enrollment, employment history, that's a part of. And this dotted line is saying that this is an attribute, or it's a weak entity that wouldn't exist if we didn't have this relationship. Looks kind of similar in terms of diagramming, especially when we leave out those diamond symbols. So diagrams look very similar. It's kind of showing the same thing in different ways. Now, recursive relationships are a little different, however, in terms of their representation. You can actually show a true recursive relationship in UML notation that you can't really do very effectively in an entity relationship diagram, because in an entity relationship diagram you're not showing roles or associations, you're just showing relationships. So all you can do is say that a person has a relationship with the person. This could be staff and managers, or employees and managers or whatever. So in UML, you can explicitly constrain the relationship very precisely. So we have a recursive relationship on the class employee, and employee can be indicated by the constants, by essentially the two different roles here. So we have a person who is an employee managed by a boss, and so we have two kind of classes in the tree that we can line up and just overlap them essentially to show that we have two different roles. You can be an employee, or you can be a manager. You can be a boss. So we have the person and the boss, essentially. It's not really two separate components because they're overlapping. They are together in terms of one, they switch roles back and forth. So basically showing you the roles. We also have components in the UML diagram. So in this particular class diagram, comments are graphically represented. This is the notation. These are just examples of some of the things we've seen already in terms of the notation. This doesn't exist in an entity relationship diagram. Do not put comments on your diagrams. It'll look like part of the diagram. But that's supposed to be like one of those post-it notes where you take this side and bend it over, stick it on something, stick it on the refrigerator. So what we're doing here is we have a text object here that is attached to the UML diagram. No comments in entity relationship diagramming. The naming of the associations is pretty much the same as the naming of the relationships, except for we have many different associations and we only have one relationship. So rather than naming both sides with a verb phrases in terms of the entity relationship diagram, in UML we name once and we put a directional arrow that is added to tell us which direction we want to read it in. So it usually points to the many side of the one relationship. So employees work for a department. And here's the interesting phenomena, and some of you, usually a couple people at this point, start looking at this going, wait a minute. You've shown me entity relationship diagrams with arrows like this before. And I have, actually, in a couple weeks ago, I showed you entity relationship diagrams with arrows and names. Here's what's happened. We've worked backwards. It's very common these days. In fact, this is why, if you've seen any of the older entity relationship diagrams, the attributes are always outside of the objects and they're like in little bubbles. And then now all of a sudden, oh, the attributes are now inside of the entities. Oh, well, that came from a UML notation. When all of a sudden we started having classes with those 3 different sections in it, identity, states, and behaviors inside of a class box, all of a sudden now the entities look like classes. And then in the old days there was a diamond symbol that was used for the relationship. The diamonds are almost gone. They faded. They were originally introduced because we could show different degrees, 3, 4 participating entities all in the same relationship, and we'd have like a line to, you know, smoothly attach all of the different entities. We still see them used for that purpose, but when there's a binary, one entity that has a relationship with just one other entity, the diamond generally goes away. And then the notation goes to a UML style sometimes. And in fact, some of the tool sets for entity relationship will show you UML notation, which is kind of interesting. So we're kind of fading the line between entity relationship and object or class diagrams. So it depends on how you learned how to do it as to what symbol set you're going to use. But the interesting thing is although we are creating an entity relationship diagram, we're using the UML symbol sometimes, and then we're not showing UML because we're not showing the associations, we're showing the relationship instead. So the diagrams themselves, my point is that the diagrams themselves can be extremely confusing to look at, which is like you can look at this and go, if I change the label, took UML off of here and put entity relationship, move this arrow to the center, it would sort of look like an entity relationship diagram, modern day. This one's never going to look like UML though, because we don't have crow's feet, and these should really be rectangles, they shouldn't be ovals. And here are the employee that works for a department, so many employees. This is supposed to be crow's feet, work for one department. So it's an employer of a department. And here is the same idea, but in different concept. But most of our modern day entity relationship diagrams are looking more like that than they were from the beginning. So the notation style is definitely upgraded itself with the introduction of object orientation, which makes it confusing. And again, there's no standard in entity relationship diagramming either. It's not a standardized concept. So without standardization, we don't get consistency. Nothing has to be a certain way, so people have their own ideas. In essence, you could actually be doing object-oriented analysis and design, but still thinking in an entity relationship structure, but never creating an entity relationship diagram if you start out with the class diagram or the object diagram. So, generalization, interesting concept. It exists in UML, does not exist in, it's more flexible, but it does not exist in entity relationship diagram. So it's more flexible than the relationship. So in entity relationship diagrams, all we have are entities, relationships, and attributes. So UML, we have associations instead of relationships. But we also have generalizations. And then we have different characteristics, so associations and generalizations. More often you'll see the association versus the generalization. But it's basically all replacing the relationship concept. So there's not, there need not be only one generalization structure for a given particular class. So you might have multiple generalizations that are operating on the same class. And here's a classic example of what you can do in UML that you can't do in entity relationship diagramming. So a consulting contract, which can be time and materials or fixed cost and independently classified as a government or private. So we got government, private, fixed cost, or time and materials. Let's look at the UML as an example. This is a generalization, meaning that it can be a fixed price or it can be a time and materials costing. Or the origination type, not the billing type, but the origination type. And these are two generalizations, and you'd label this, you know, generalizations. You'd label it, you know, billing type. You could put the word on there, or you could leave it off. It's classic just to see it left off. And then we have private and government. That doesn't necessarily mean that we have a relationship between both. We have the option of full or partial participation or no participation. So if we were to do the same thing in an entity relationship diagram, we can't connect any dots. This would be a rectangle with rectangles inside of it, or a bubble with bubbles inside of it, but the problem being we can't show the generalization. We have to show that there is a relationship. But there might be a contract that is just fixed price, that doesn't use time and materials. So, long story short, we can't really show it because the toolset doesn't lend itself. So when you're basically looking at generalizations or associations, you take the UML route. And if you're thinking along those lines, you're probably looking at an object-oriented design anyway, because otherwise you would not be using that type of terminology. So beyond entity relationship diagramming, UML allows the creation of all sorts of different types of general entities, class relationships, associations, all sorts of different things above and beyond what an entity relationship diagram is going to show you. And here's another example in terms of what it contains. We have interaction diagrams that we don't have. And I'm not going to go through, and you don't actually have to create all of these diagrams. You have to create a component level diagram, and you have to create, or actually it could be made from your entity relationship diagram. So you have to do a data flow, an entity relationship, and then one UML. And this is true for both the analysis and also the design document. And if you want to, you could do an interaction, a sequence, a collaboration activity in one of these other diagrams. And we'll take a quick peek at these to see what they look like. But I'm not going to go through all the different diagramming techniques for it. In fact, once you learn how to do diagramming in general, they actually kind of just, they're just different variations. You get the tool, you get like a Visio or something, or you get a tool set that works with it, a rational rows, or one of the object-oriented analysis and design tools. And they have templates, so you can see pictures of what the diagram is supposed to look like and drag and drop the symbols. So an interaction diagram is a set of objects and relationships, including the messages that are dispatched among them that go back and forth in terms of the interaction. Interactions could be sequence or collaboration. Sequence, the time ordered of the messages. The collaboration might be which objects are sending and receiving, which objects are working together on something. In terms of the activity, we're looking at the flow of the control from activity to activity. And then we have the state chart diagram that models state machines. So here we can show actions on objects, and these are the same symbols that are being used in all of the different types of these diagrams. So the call looks like a method call with a parameter in there. Okay to borrow, and then comes back and says okay, like a return call. It's return a status of something, and so most of these are arrows. They create the destroy, showing you an action in terms of the behavior of the association. Send, modify, return. So here was a UML that can show a link between a library member and a copy of a book. So again, we're looking at a class diagram, but we're looking at the link between the two classes. And so this is the same example that we looked at in the last lecture, actually, with the borrower in the library. And we have a lot of this notation here is put here to kind of document or to show you what it is, label what it is you're looking at. This is an association, so we have a copy of a book that's on loan, and the library member said we could borrow the copy, or you're going to return a copy. So the library member is working with this copy of this book that's on loan, and showing you the relationship or the association between the copy of the book and the library member. Now, the copy of the book might have a relationship with the person who borrowed it, but they have an association with the library member. And then we have the library member, which is the object, and then we have the copy, which is an object, and then we have a message that's being sent. So that's why we have these arrows essentially showing you the link between the two, which is like, explaining the line concept. And then here's the sequence diagram of kind of a similar scenario, sequence numbers added to messages. So we have one where we have a get name. It goes to the engineering student object and gets the name of the engineering student object. So we're running a method, essentially. And then it returns the name. So in here are the sequence numbers, 1, 1.1, 2, 2.2, 3. They're just basically showing you the sequence of the exchange of information. And then in the second exchange, a new student is created. Think of these as method calls if you want. And when you run new student with a name to create a new student, it goes out to the student object and creates a new object. So we have the creation of a new object. And then here's item number 3, might be, destroy the object. After we created it, why we created it, I don't know. Why we destroyed it, I don't know. And the sequence is going to basically show you what happens when you send a message to an object, and then what gets returned from the object. And then what happens when you send this other message to another object. It's not really showing you the collaboration, not showing you the classes, but it's showing you the sequence of events when running methods. Here's a sequence diagram for borrowing a copy of a book. So we have the library member over here, library member object, the book object, the copy object. And so the method to borrow, so what are you going to borrow? You're going to send a parameter of the copy. And it goes to the library member, and it says, okay to borrow, okay. And then borrow, then, if we're okay to borrow. So there's a check here that says, and this is kind of like a data flow diagram in some ways, but it doesn't look like a data flow diagram because we have process bubbles that appear here, and these process bubbles are kind of doing the logic. But rather, instead, we're showing the sequence. So the borrow method sends something back and says, okay to borrow, not okay to borrow, because maybe the user has like a ton of books on loan already and hasn't returned anything, and the library member's not going to let them borrow something again. And then borrowing, if it's successful, as an example, the copy. Is there a copy of the book available? Because there's not just one book in the library. There's many different, like 5 different copies of the book. And so the copy is going to go, well, is it borrowable? Then go to the actual book. It's kind of like when you buy something online and say, hey, there's 5 of them in inventory. Okay, go get one. Until they actually find it in inventory, you can't buy it. But the system says there's 5 of them. So this is kind of like the same process of showing the sequence of going from a copy to finding the actual book. So. And you can see you can't do this in entity relationship diagramming or data flow diagramming. It's not showing you the sequence. Data flow, as I mentioned before as a side comment, you could turn this into, I could not really turn it into, you could create a data flow diagram that would show similar processing. In this case, we would have process bubbles that said, process the request to borrow a book, process the request to borrow, and then return the book. And then all of the activities could be diagrammed out. There's a class inheritance diagram where we have an interface, and then this might look familiar, maybe not, it doesn't have to. But these are all of the inheritance. Everything in Java comes from object, and then we have component, container, panel, and then applet is part of panel. And hello world is part of applet if we were to make it an applet. If not, we'd make it part of panel if we were going to do some GUI application development. It's basically showing you each of the classes in a sequence, and obviously the list was too long to fit on the slide, so we had a arrow going this way, which is kind of common. You'll see a whole page of it going this way. Or you'll see it in really small print, kind of next to each other. How you do the diagram's up to you. Here's an activity diagram using a process model. Kind of a hybrid between a data flow and an entity relationship, but it's not really showing any entities, it's only showing the data. So I would think of it, this symbol kind of tells me it looks like an entity relationship, but it's not an entity. So it's more of a data flow, but it's not really data flow either. So it doesn't meet any of those entity relationship equivalences. So what do we have? We have a process bubble. Well, we see those in data flows. Release of the work order going to another, materials not ready or materials ready, a decision. So this is more of a decision in terms of an activity diagram. You can think of this more like an old-fashioned flow chart. Is it going to go this direction or is it going to go this direction? And you could have used, this is the same decision symbol that was used in the old days for flowcharts. So if the materials are not ready, then reschedule it. If they are, then assign some tasks. So just showing you the flow in terms of the processing. And then we have parallel activities. Try to show this in an entity relationship or a data flow. It doesn't work either. And what are we looking at here? We've got a start state, and then we have a decompress. Okay, we're translating video or audio, multimedia, converting it. So we have a, let's call this a DVD. We have the video stream, and then we have the audio stream track of the DVD that we want to do something with. We can fork off an event to say decompress it, and then we can take this stream, take that stream in parallel, do some processing on it, and then put it back together, join it together for the final state, which is going to be the outputted translated file. So if we were ripping it, cutting it, to translate it from one format to another or something, we would have to go through something like this. We would actually have to go through this to play it too, actually. The audio and the video get separated out in terms of the live streaming of the content. So sometimes you turn on the TV or something. Usually happens with digital cable for some reason. The audio track makes it there faster than the video or something, or than the stream data track, and then the words don't match the person who's talking. So. Straight state diagram showing you the state of a class book. And here's a state in terms of is it borrowable? It could be borrowable, and sitting here in kind of what would be called a state machine kind of state, in which the book, borrowable books just sit there. It's kind of like, items in a store, kind of just sit there waiting for someone, kind of a wait state. And then if it's not borrowed, it could go into a borrowable state, and then it kind of goes back and forth between being borrowed and then not being borrowed. Kind of like a network protocol, or a network activity software that sits there and listens for information that might be coming through on a port. If it finds something, it does something, and if not, it just sits there and waits. So you can't diagram that in an entity relationship or a data flow diagram either. So in terms of UML models,